2025 paper 2 question 7, and we're told to measure these lengths, which I can't really do on a video, but basically you just take your ruler out, you get R to be 1, you get D to be 10, and you get H to be 3, and that's that part. In part 2, we're told the actual total length, and we're used to use that to figure out what the actual lengths are for R, D, and H. So basically the way we can think about this is, if we think about this entire thing as 14 different segments, because when we add all those R, D, and H up, we'll get 14. Well, then 1 out of the 14 is taken up by R. So 1/14 of the total length is R. 10 of the 14 segments, so 10/14ths of the total length is going to be D. So 10/14ths of 90 will give us D. And then 3/14ths of 90 will give us H. Then when you do the proper rounding, you should get R is about 6.4 and meters. Well, they say to fill it into the table, so you don't actually have to write meters because it already says meters there. We got R is 6.4, you'll get D is 64.3, and then you get H is 19.3. And you can double check your answer by adding all those up and see that they add up to 90. Then in part B, we're given a different submarine, and we're given these lengths. We're told what the volume is, and we're told to find the total length of the submarine by solving an equation in X. So the total volume, we just need to add up the volume of these shapes. So the first shape, this is a a hemisphere. So the volume of a sphere normally is going to be, well, first of all, I'm just going to say the total volume is 6,738. That's going to be equal to, so we're going to have the volume of a sphere, so it's 4/3 pi r cubed. You can check that in the tables book. But it's and the radius is going to be x, as you can see. So we can actually just say 4/3 pi x cubed, but obviously it's a semisphere, so we're going to multiply that by half. And then we add to that volume, then we have the volume of a cylinder, and the volume of a cylinder is pi r squared h, so we'll have pi, and then the radius is x again, so we're going to have x squared, and then the height, you can see it's 7x there. Plus, and then we have the volume of a cone, and the volume of a cone is 1/3 pi r squared h, so we'll have pi, the radius again is just x, and then the height is 4x, and it's pi r squared h, so it's x squared times 4x, and then we can just simplify, so we're going to get 2/3 pi x cubed, plus, and then here we're going to get 7 pi x cubed, and here we're going to get 4/3 pi x cubed. And we can add all those together. They're kind of like terms. One way you could think about it is if we factor out the pi x cubed from all of them and then just add up all the numbers in front, or you can see they're all like terms, so we can kind of add like terms. When you add all those up, you'll get 9 pi x cubed, and we know that's equal to 6,738. So we can divide both sides by 9 pi and take the cube root, and then we get x equals 6,738 over 9 pi to the power of a third, or we can say the cube root, kind of the same thing. So you can figure out what x is then, and we won't actually say what decimals yet. And we get 6.1998, so that's very close to 6.2, that it's kind of okay, just say 6.2. And we want the total length of the submarine, so we can just multiply that by, well, the total length is going to be x plus 7x plus 4x, so that's going to give us 12x, so we can just multiply 6.2 by 12, so 12x is the total length. So we're going to have 12 times 6.2, which will give us, it'll give us 74.4 meters as our final answer. Then we're given some information, and we're told to write down the equation of circle S. So basically we can just look here. So S has center and radius. So we can just fill that into this equation here, which is in the formula and tables booklet, where HK is the center. So H is the X coordinate, Y, or K is the Y coordinate. So basically when we fill into that, we'll get X minus 20 squared. And this is just reading from the thing I underlined and read above, of plus Y minus 0, the whole thing squared. So we can just say plus Y squared equals, and then the square root of 178 squared is just 178. And that is the equation. Then we're told to verify that the point 73 lies on circle S, so we can just sub in. So we'll have 7 minus 20, the whole thing squared, plus 3 squared, and calculate what that gives you in your calculator. When you put that into your calculator, you'll get 178, so you can give that a tick because that's equal to 178. So if this equation is true for the point 73, it lies on the circle. Then we're told to use these points to find the area of the triangle DBC. So if you look in the diagram, and I'm just going to kind of draw it down here. I'm going to drag this diagram down. I'm going to draw it out myself. So the point C is 7, 3. Then the point D is just beneath that. It's 7 minus 3. And then the point B is over here, and that's the point 20, 0. So we know that these two are directly above each other because they both have x-coordinate 7. So that means that this is kind of perpendicular to this, so we can easily just find the base and the perpendicular height. So the distance between these 2 points is going to be 6, because between 3 and minus 3, 3 minus minus 3 gives you 6. And then here the x-coordinate is 7, so the distance between 7 and 20 is 20 minus 7, so this is going to be 13. And all these distances are in kilometers, so the area will be equal to, because we're told to find the area of the triangle, so it's half the base, which is 6, times the perpendicular height, which is 13, which will give you, 39, and then that's in kilometers squared as the area. Then we're told to find the size of CBD, the angle. The fastest way to do this is to notice that these two right angle triangles are congruent. So we can just find the size of this angle using our simple trigonometry and then double it, because the green angle here is going to be the exact same. So basically what we have is, I'm just going to call this point here, I'm just call that point X. So between C and X, the distance is 3. So I'm just going to kind of draw my triangle down here. So we have C, X, and B. And basically, this distance here is 3. The reason being, the distance between C and D is 6, and it's just cut in half. We know that the length of the triangle, this side is 13, and that the hypotenuse here is 178. You can see that in the diagram. Here's our right angle. Here's the angle we're looking for. I'll just call it theta. So we can kind of use whatever trigonometric ratio we want to use. Like, for example, if you didn't clock that this is half of 6, it's fine, because we still have the other two sides. So this is the hypotenuse. This is the adjacent. So we can say that cos of theta is equal to the adjacent over the hypotenuse. So it's going to be 13 over root 178. And then the angle CBD, it will just be double that. So theta will be the cos inverse of 13 over root 178. So basically CBD will just be twice the cos inverse of 13 over root 178. I haven't given this as a decimal yet, because for accuracy I'm going to double it first and then give my final answer. It doesn't really matter too much, that's just why I'm doing that. When you put that into your calculator, you got 25.989, so that rounds off to 26 degrees, because we're told the nearest degree. Then we're told the area of the sector ADC and the area of the triangle ADC, and we're told to find out the shaded region on the diagram. So the way that we're going to do this is we're going to find out, so we're told this area, I'm going to probably just copy this diagram, it's getting a bit messy. So we're told what this area is, this area right here, the curved area. If we add to that this area here, so that's the other area of the other circle, when we add those two areas together, we're kind of double counting this area in the middle for the overlap, but then if we subtract the area of the two triangles, then we're only left with that overlap bit. So again, what we're doing is when we add the area of the two sectors, we get the area of all the triangles, and then we get this overlapped bit added on top, and if we just take out the area of the rectangles, then we're just left with that overlapped bit. So we first of all need to figure out what the area of the sector CBD is. So we know it's about 26 degrees. So we have, let's just say area of sector CBD. So that'll be equal to, it'll be pi r squared, but then we only want 26 degrees out of the 360 degrees. And the radius is 178, you can see for that one. So the pi times 178 times 26 over 360. And let's do, well, I'll just leave it like that for now. And then we want to add those together. So we want the area of sectors, and then we want to take away the area of the triangles. Again, and that'll just give us the overlapping part. So the area of the sectors, so we'll have 178 pi times 26 over 360. We want to add onto that the area of the other sector, which is 23.4837. So plus 23.4837, is that correct? Yep. And we want to take away the area of the triangles. So I believe we found out, yeah, the area of the CBD triangle we found to be 39 square kilometers. So we'll take away 39. And then the area of this triangle here, we are told is 21. And then when we compute that area, what we get is we get 3.87 kilometers squared. And it says 2 decimal places, so that's why we're giving it like that.